Hello students, so in this lecture we will be discussing about photoconductive cell. Now it is a semiconductor device whose resistance varies inversely with the intensity of light that falls upon it. So resistance varies inversely upon light intensity. It is also known as a photoresistive cell or photoresistor. The resistivity and hence the resistance of the semiconductor depends on the number of recharge carriers available. So R is actually a function of number of recharge carriers and when the semiconductor is not illuminated, the number of charge carriers is small, hence resistivity is high, but when the light is in the form of photons strike the semiconductor, each photon, so when we are talking about light, we are mainly talking about the photons, each new, when they fall on the semiconductor, so each photon, it creates, delivers energy. If the photon energy is greater than the band gap of the semiconductor, free mobile carriers in terms of electrons and holes are generated. So it causes free mobile carriers. So that's how the resistivity or the resistance comes down. Coming to the construction of a photoresistor. Photoconductive cells are generally made up of cadmium sulfide and cadmium selenide, and the spherical response of CDS cell is similar to the human eye. Hence, each cell are often used to stimulate human eye. And this is why we find these circuits or we find these cells in photographic cameras. Now, the construction of a photoconductive cell, as it has got two alternative circuit symbols, like it is you have a lens, and you have a photoresistive semiconductor. So this is a photo sensitive semiconductor. So either you can represent the photoconductive cell by this symbol, or you can represent it by this symbol. Now, a thin layer of photosensitive semiconducting material is deposited in the form of a long stripped zigzag across a disc-shaped ceramic base. So this is a long strip zigzag on a disc-shaped ceramic base with photoresistive sides. So these are called photoresistive sides, and this is a disc-based ceramic plate. For added protection, a glass lens or plastic cover is used. So this lens or plastic cover, it provides the protection to this photosensitive semiconductor. Now the two ends of the strip are brought into contact, connecting pins in the base. So these are the connecting pins. Now the terminal characteristics of the photoconductive cell is shown. Like if we go to the IV characteristics, so if we put here, say, cell resistance, in mega ohms, and we put illumination flux, intensity of light, and it is, or you should call it as lux, or illumination, not flux, actually illumination. So it follows a plot like this. So this is 100, this is say 1, and this is 10, and this is 1000. So this shows how resistance of the cell varies with light intensity. Typically, the dark resistance of the cell is, it means if there is no light, is 1 mega ohm, and or large. Under illumination, the resistance drops to a value between 1 and 100 kilo ohms. So there is a drop in the value of resistance with the intensity of light. The application of photoconductive cell, considered the application of the photoconductive cell in detector or sensors, whatever you may call it, detector or sensors, and in an off-arm circuit, and light measuring and light detecting circuits, for light measurement and light detection.